G'day guys, got a GPX4500 that I've been doing some playing with and made some good ground on this one. Done a lot of stuff on this detector and even configured the whole input stage on this detector, and it's made a big improvement. So it's about 9:30 at night here, and everyone's TVs and things are on, and there's a bit of noise around the place, electrical interference and so forth. Not as bad as what it is during the day, but it doesn't really get quiet until after midnight here. So anyway, we got the old, well, it is an old one. It's a first edition GPX 4500. Got it sitting in normal timings. I've got the audio up on range of about 60, just so it makes it clearer to hear. Well, I think so anyway, but we'll see. I don't know what the frequency response of these microphones are. It may not be that good. We'll find out. But anyway, it's on factory standard settings, except for the audio, normal timings. I was going to show you what this one does. I'm going to wind this up so I can get onto the coil. I've got to keep this away from the coil and the detector. This iPhone makes interference. So if I'll lock that in there. There's the coil. We won't use the 0.1. We'll use a little 0.05 specky thing sitting in there. Okay. And what we'll do, I'll just put the ruler there so we can get an idea of how far we can detect this. Remember, in normal mode with the GPX 5000s, with this target, we had to scrub the coil to actually hear it. But not in this. It's absolutely loud as. It's 4500, so it's a little bit different, but anyway. And yeah, normal timings. Helps if I go across the middle of the coil too. I'll put that back so I can do that. I can just get it on 10 centimeters. That is a big jump from where I can normally pick up that tiny thing on this coil. It's double D coil. "10 centimeters. It's a bit of chirp. Without that chirp, I could probably get it further. But the big test on doing all this stuff is, does it still reject ironstone hot rocks? Like, that's a nice heavy wad of ironstone. Go over here and I have to get behind the camera so I see where my hand is, because I've got no idea. Magnets, hot rock, bonk. That's pretty decent hot rock. And now everything wants to stick to the magnets and become magnetized. Okay, there's a hot rock. Let's see what this does. I don't even know if it's in tracking. Probably. Let's see. I've got it in slow tracking, but I'll just speed it up. One flick. There you go. These detectors, they go into 10 seconds fast tracking. If you go from tracking back to fixed, then back to tracking, it tracks fast. The double D probably depends whereabouts I put it on the coil to where it knocks it out. If I put it on the windings, it'll make a noise. If I balance it on the windings, it won't make a noise. I take it off the windings that run underneath, it'll make a noise and so forth. But fast track. pretty good. Nothing wrong with that. And that's in normal mode. So, that's doing really, really well. And actually, it's pretty quiet. Give you an idea how sensitive this thing is. I'll show you because I've reconfigured the front end. It does need, it's super sensitive. So I'll just give you an idea, and you get an idea how sensitive it is. Okay. Now, if I just introduce some wafts of air over it, listen to what happens. Well, how about I blow on it? You hear the tone change just by having air go over the components. So yeah, blow a bit of air over it, and it does have an effect, just changing the thermal stability of some of the input components. But that's absolutely amazing to work that well. I'm absolutely amazed. Like I say, it's got nothing else on it. There's no extra boards. It's got a lot of bypassing done to it, and I've swapped out the input stage MOSFETs and done a bit of inversion in part of the circuitry, and it's going really, really well. So we've got to think back to the GP series detectors. Well, let's turn that off. It's driving me nuts. We've got to think back to the GP series detectors and the way the input stage was done on those detectors, and the reasons why it was done a particular way. And on these later detectors, they've done it differently. What they've done, they used to, on the older detectors, use N channel then to P channel to block the high voltage positive going spike, and use the P channel to block the transmit voltage, basically going through the diode on the first MOSFET, conducting it through to the second. Basically you'd have reverse conduction through the body diodes trying to block the spike, but the negative going transmit spike, or transmit pulse going to the coil, would still go through the body diode of the first MOSFET and then get blocked by the P channel, because it is configured around the wrong way. So you'd have in the body diodes, it would go cathode, anode, then it would go anode, cathode. And if the MOSFETs are turned off, there's not going to be any conduction. But with the body diode, that's why you need two MOSFETs. If they didn't have a body diode, you can just use one. But what they did, they on these detectors here, they actually used NN, and what they did is they transposed the drain and source connections on the second small MOSFET, and utilized it in that configuration, which it does work, but I don't like it. And if you can see what I've done to this one, I don't know if you can see from that distance, but I reconfigured it back into NP. And it's an absolute pain of a thing to do, because the MOSFETs are around the wrong way. You got the wrong drive on the gate, it needs to be inverted. And what I've done with this one, I've inverted it and put in some low noise MOSFETs, P channels in there, and isn't it amazing? The gain goes up, right? Just as I thought. The other thing about using P channel devices as well is they're less noisy. They actually create less noise in themselves, as they are minus a substrate layer in the FET, which is everything inside these things is partially resistive, or because it's semiconductor, and generates noise. So you get all sorts of thermal noise, random electron noise. I'm not going to go into all that. It's too complex. Well, boring. And P channels are quieter. The reason why people don't like P channels because they usually have more capacitance. They have more requirement for gate, drive to overcome the gate capacitance. It is higher to get the same low on resistance. But the modern P channel MOSFETs are very, very low gate charge or low gate capacitance, and not a problem. I'm getting sub 1 ohm for about maybe 30 picofarads of gate drive on these ones, and that's nothing. That's neither here nor there. So there's no problem going back and reverting to using P channels. I wish the input stage was a P channel, but very, very difficult to get good low ohmic resistance in a high voltage P channel FET with the low capacitance. Even the gate drive on these robs signal from the input stage. Even the gate's a capacitor across drain and source, and it's going to say, well, I'll take some of that signal and I'll dump it down into the drive circuitry, which usually referenced to ground somewhere. So there's points in isolating that. You have a look at the drive on these things. It's all direct drive onto the N channels on the input, and cut the track, put a resistor in there as well, and it should have a resistor on each MOSFET, by the way. And maybe people go, oh, I can put 10 ohms there. On these, the capacitance is so low and the charge so fast because of the low capacitance, it has no bearing on the operation of the detector. Use 100 ohms. It's really good for isolation, and anything coming in, ripple in the power supply is not going to modulate the gate of the FET and then transfer it on the signal. You don't want that sort of stuff. So that's this lovely GPX, and I'll tell you what, I'm really, really impressed with that. Actually, one thing I didn't do, I didn't hook it up in Enhance, did I? Maybe I should do that. I'll flick it into Enhance and see how it goes. We'll get down here, and there it goes. It's on a bit of a noise frequency by sounds of it, because of Enhance's different timings, but so be it. It may quieten down a little bit as everything drifts. You remember these things have the main oscillator for the transmit receive is not digitally controlled or anything. It's an LC oscillator, and they do that more than likely to get phase noise down, get rid of jitter and things getting into the receiver. But running it here in the workshop is enough jitter because of interference. You can hear it anyway. There's all sorts of woofy interference coming through now. It'll probably go away. Yeah, it's making sure it's not the microphone. It might be, I don't know. But all these detectors are normally more noisy in Enhance. The reason being they turn on the receiver faster after flyback, and it can, be a bit woofy. Anyway, actually it's doing it about 8. That's really interesting. It's actually working better in normal mode, which is quite amazing. I'll just flick it back in the normal. Here, normal mode's heaps quieter. It always is. few woofy things coming through, but enhanced tends to pick it all up, and every transmit cycle when the receive comes on, it comes through. This is sort of hit and miss, but yeah, get it at 10. I was trying to push 11 then, but yeah, about 10. But it's a lot quieter. And we'll just gotta watch and make sure I hit the right switch, because if I don't hit the right switch, it'll do something crazy. It's back in enhance. It's probably just landed on a because the timings are different. It's landed on a different receive frequency for the interference. So maybe that's why it's a bit woofy. Yeah, it's woofy, chirpy, woofy, what you want to call it. Hang on a second. I'll move this. I'll change the frequency on it. Where are we? Okay, I've gone up 2 notches in frequency. That's quieter. Okay, not so bad. So it was on a noise channel. Didn't know where I put my magic stick. That's better. Get rid of the noise. Get rid of that interference. Then get it up at 10. That's all right. So any interference, any noise, absolutely kills these detectors, kills the performance, especially when you're listening for, very soft signals. Any, wavering noise coming in absolutely kills it. So not a good thing. Not a good thing. And I think I did this before in Enhance, and Hot Rock. Just flick it back in the tracking fast. Do it again. It's on slow track. There we go. Yeah, I've got it set on very slow for tracking. It just basically helps with the noise. It acts as a bit of a filter and gets rid of some of the chirpiness. So out in the field, I wouldn't normally have it sitting there. I would move it back into maybe slow or medium tracking. You get away from suburbia and there's no noise. It's very difficult doing this here. There's just so much noise around the place. So there's that thing. I'll just drop this down a bit. Okay, I'll just disconnect it all, point out a few things with it. There's a few things that God, that's tight, that one off. I'll take the mylars out just in case I stress them whilst wiggling this around. But I have to get behind the camera and work from behind doing this because I've got no idea where I am. Okay. Don't know if you can see there. You can see a couple of little tiny black dots. They're the MOSFETs with some gate resistors, and I've got them coupled into the drive from the BF908 to, for a phase inversion, because it's got to be completely opposite to how the drive is for the N channel FETs. We go under the board and you can see where the 2 FETs are there in the middle of the screen. Don't know if you can see it, but I've cut the track and I've put a resistor there. it makes it a lot quieter, a hell of a lot quieter. The other thing I've done as well, I've added a whole heap of low impedance caps across various points, getting the noise out. This one here, I think device up there, whatever it was, 40106 I think it is, blew up. I had to replace that one stage. And I think it's also got the modification for the power supply glitch mod, turn the switch on, off really quickly and the detector blows up. Takes out the power supply. And that's in here. There's a resistor added and a BAV99 diode. You've got to cut the track and you put the resistor and the diode in there. Because nothing worse than going out and blowing your power supply up. The other thing too is that flyback stabilization MOSFET there, it's been changed. I don't like the IRF 9630s. I put a higher voltage rated device in there because occasionally they blow up and there's not enough current there to take out the MOSFET. It has to be some strange voltage event, higher voltage than what the device is rated for. And I don't know how it gets passed or what goes on in that regard. But once I've replaced this MOSFET here, I think that one there's rated for 250 volts. So the other ones are only rated for 200. And I've never had one ever blow up, and I've replaced those in many people's detectors and never heard about it ever again. It's just a funny combination that particular coils, out operating the detector for a while, and that thing there will just go dead short circuit. It'll just pop. It can go open circuit too, and then you'll find about 300 volts over your circuit and takes other things out. So you always want to pray. It always goes short circuit when it goes. You don't want it going open circuit. It has done, and it's a lot more repair work. And the repair work you've got to do is all around that device there. Pretty sure it's a 40106. Anyway, or is it a 4049? One or the other. So yeah, always a good idea. Just replace that thing anyway. It sits there. It's always getting pumped by the flyback voltage going through. And I don't know what happens. Maybe the coil connector comes loose, and when it reconnects or something, it puts a huge spike in there, and it's not fast enough to clamp it. I don't know what happens. Maybe the feedback system goes out of lock, or it's no longer keeping up or something, and it pops that MOSFET. It's a common occurrence. So I've replaced probably, I don't know, somewhere. Well, I bought a reel of 100, and I've probably got about 5 or 6 left. So yeah, they do blow up. Apart from that, it's a very, very nice detector. With this one here, I think I will put variable gain boards in it. Basically, it's lower noise again, and as I've improved the noise figure ever so slightly by putting in those PFETs, it's a secondary, signal transfer or high voltage or voltage blocking devices, depending what they're doing at the time. We can get probably some more performance out of it. So this will be a very, very good detector. Now, what I've noticed, just doing experiments here, like we've been doing experiments with the 6000, then I'm basically getting similar results, detection depth wise and so forth, with this as what the 6000. You can probably do your own experiments. Similar size coil, just get a similar size target and have a play, see what your detection depth is. And the other one is too that on the 7000s, we've been doing the upgrades on the 7000s, and the feedback is, and you can have a look at people's testimonials in the videos, and we got some by email as well, that everyone's getting on average between 12 and 20%. Now that 20% sounds like way too much to me. That would be very, very small gold and probably fringing effects. As the size of the target gets bigger, your percentage improvement would normally reduce. But like I say, you can look at it here. Say you get a 5,000, and the way it's normally configured, and we've got to rub the coil in normal mode to get a signal off a 0.05 thing on the stick here. And after we can do it up, we can pick that up 6, 7, 8 centimeters. So, what's that? 1,000% difference? I mean, whatever you want to call it. It's, that's a bit fictitious saying that. But, even if it was 1 centimeter and it suddenly picked up gold and handled the ground, everything at, even, 2 centimeters, what's that? 100% improvement? you know, well, if it was standard, you wouldn't hear that target. You would walk over it. That's obvious. So, as long as the noise is low and you're not introducing noise into the circuit, you can get a lot out of these things. So, yeah, that's where we're at. So, yeah, we're quite impressed with the feedback on the 7,000s, and the 6,000s. We just do a little bit of extra intricate work inside those. They come up better too. We finally had a look at some of the mechanisms of that feedback and understand how that works and how to cure it. But that Minelab's doing that for free. So people tell me, you send your detector in. I think you've got to pay for the postage, and they do that. So yeah, I got caught with that. With a detector came in, the fellow sent it to me. He said, "Oh, go out and have a play," and I did. And what do you think? Oscillator went nuts, and that's a feedback problem. So that's an interesting one. Yeah, very very much like I remember the I don't know if you do, because if you ever had one, when the 4,000s came up, they had that push button switch. People would get them brand new and they go out in the goldfield and they push the switch, it wouldn't turn on. um, yeah, so there's funny things happen. Funny things happen. Exploding power supplies and detectors because they turned it on and turned it off and back on again. Within 30 seconds. So that's that. Diode and resistor modification and the cut track. Stop that happening. Old 45s probably still have that problem. Depends on you'd have to look at the revision number on a circuit board. So if it was like 1 or something like that, you'd probably say, well, maybe it's got that problem lingering, but maybe 1.1, 1.2 or whatever it may be, that's been fixed. So you can always check for that anyway. Where I showed, just have a look and see if it's got the cut track and the diode and the resistor put in there, because you don't want to go out and have your detector die on you. That's not good, especially if you're in the middle, of whoop away from civilization and thing doesn't work. Well, my answer to that is always take 2 detectors. Always have a backup, just in case. These things, any electronics can fail. Even your car ignition system can fail out in the middle of nowhere and you'll be stranded too. So you've got to think of all this stuff. Take a satellite phone, or have Starlink system. You can always have a bit of comms and get out of trouble if you're out in the middle of nowhere. Yeah, anyway, that's enough waffle. The point of the exercise was to show that these detectors can be as good as the new ones, right? They can. Maybe some aspects like the say the 7,000 with its flippity gibbets transmit circuitry, bipolar transmitter, gets rid of some of the ground mineralization effects. Maybe that's a good thing. I've never gone and used one on a target in heavy mineralization and compared it to one of these and say this one gets it, this one doesn't. I'd say that if the older detectors are working fine, they probably get it anyway. Maybe it's slightly noisier or something. I don't know. Never done it. So I can't say it would be or wouldn't be better. I don't know. But these things are as sensitive as hell when they're done up. They really are. Anyway, it's enough waffle. Let's get into that time. It's 10 o'clock. That's 30 minutes of mucking around with not so old. Well, yeah, I suppose first generation 4500s getting a bit old, but they still work really good, you know. Yeah, anyway, that'll do me. Catch us later.